Bonjour, hello. So it's a pleasure to be here. I'm afraid I don't speak Arabic or French, so you'll be stuck with my English. I'm Lucas Dixon. I'm the engineering lead at Google Ideas. So I thought I'd start by telling you just a little bit about Google Ideas, and then we'll go on to technology, information, and anti-corruption. So Google Ideas is a think tank in Google. What we do is we explore how technology is changing big global challenges. We try to understand how it's transforming both the way we understand them and the way we tackle them. It's best understood perhaps by a bunch of different things we look at. So we've looked at illicit networks, which has close correlations with corruption. How is it they function? How are people using technology to tackle them? And how are people using technology to understand them? So today I'll talk mostly about technology, but I want to start off with two little anecdotes, two pieces of technology that are currently being used to explore, understand, and change corruption. So the first one is IPaidAbribe.com. So this is a site which started in India, and it crowdsources reporting of corruption. That's right, people are voluntarily going to the site, and they are saying, I paid a bribe. So they write down things like this one you'll see right here. They say, I paid a bribe to be able to get my driving test, because otherwise the instructor would make me fail. So lots and lots of people report these, and they get collected into a large database, and then you can do interesting things with the data. You can start to understand where bribery is happening, how it's happening, what the cost of bribery is, and then you can start to think about where you might focus and tackle it. The second example is a little story from Rio in Brazil. So there's about 20,000 emergency calls every day. About 11% of them end up in cars being dispatched. But there was a problem. The police department and the administrators didn't know if the cars actually went to the emergency. So the administrators put in GPS devices in all of the cars. They thought, we'll just track this, we'll make it more transparent. The problem is that the drivers were not very happy about this, so they turned the GPS devices off. So tackling corruption in the most obvious way doesn't always work. But the story has a kind of happy ending. So today, GPS devices and with Google Earth are inside the police radios and inside tablets. So like iPhones and things like that. So this actually helps the police map and coordinate their efforts. It's something that helps them. So the incentives to use tools that make life more transparent are important. So, like we've just seen, there's many ways to think about corruption. You might think of it like Medusa and you have to cut off its head. You might think of it like Frankenstein, an unfortunate construction of society. I'm not going to go into any more depth on what corruption is. I'm going to talk instead about bits of technology and how they might address corruption. So technology, I kind of see it as doing three things to corruption. One of them is it simplifies the way we manage information. It makes it easier for us to act lawfully. It makes it easier for us to do the administration that we need to do. If you have 100 pieces of paperwork to do to get your driving license, and you can alternatively pay a small amount and skip the paperwork, then maybe you'll skip the paperwork. So if we can automate that, we can make corruption less appealing. We can also help understand corruption. We can understand where it happens, how it happens, and how it impacts society. We can also think about engineering transparency into our processes, into our administrative processes, and thereby also providing incentives to help stop corruption. So now I'm going to jump onto technology. I'm going to tell you a bit about some fun technologies, mostly stuff we do here at Google. And so when I say here, I guess I'm based in New York. So it's stuff we do in New York and Mountain View in the US and all around the world, but this stuff is available here. And this is the kind of things that I think will make a hackathon be able to produce fun, exciting, and compelling prototypes. So the first one I want to talk about is AppScript. So this is a JavaScript cloud scripting language. So who understood what that means just from the title, a JavaScript cloud scripting language? Hands up if you had a feeling you might know what it is. Oh, so 3 or 4. Okay, so the idea is that you're going to write a program. It will be running on a Google computer in the cloud, but that this program can combine a whole variety of other services. So it can combine RSS feeds, it can combine input from Twitter, from Wikipedia. It can also use that to send an email, or to schedule an event, or to make your document for you, or to add some data to a spreadsheet. It can use that to send a GChat message. So the idea is that this is a language which you can use to combine all of the existing services, things that we provide in Google, and things that exist outside on the web, and make it very easy to do that combination. So let's look at an example. So this is a typical thing you might want to do. You might want to make a workflow for managing expenses. Maybe it's kind of boring, but making it easy is what's exciting. So the idea is the workflow might be something like this. We have an employee who's filing their expenses. They can do it on a browser or on their phone. They use something like a Google form. That's the first expense report form. When they fill out that form, a message is automatically sent to an administrator. That's the first arrow going to the right. It's also automatically entered into an App Engine database, into some data that lives on the cloud. The manager gets the email. They can then go to the expense reporting. They should be able to easily click on, like, look at the next report that I have to examine. They can either approve it, then it goes to the finance department and gets sent again automatically after they approve it, or and whether they approve it or reject it, an email is sent back to the employee. You do not want to have the manager having to write all of the emails as well as to file pieces of paperwork. This means it can be done automatically. So one of the nice things about using this AppScript framework in Google Docs is that Google Docs remembers the history of what happened in a document. So if you're worried about something strange happening, you can go back and look at the history and see what the edits were. This gives you a level of transparency into the document. So there's a bit of a question there about where does the data live and what does it look like. So there's a really fun piece of technology called Fusion Tables, which is essentially a cloud-based database. So this helps you manage, analyze, and visualize information. You can take a CSV file or some existing online data. You can import it directly, and then you can map it out. For example, at the top, we have a map done on Fusion Tables of the large internet connections in the Mediterranean. And you can see there some of the ones that connect to Tunisia. Below that, you have a classic graph, plotting a graph. What is the state of something? How does it change over time? For example, how does the connectivity in Tunisia change over time? Or finance, or expense reporting. So what's really nice about Fusion Tables is you have also a web API that you can again use with AppScript. So it's very easy to use this as a mechanism for storing and managing your data. So the problem is that a lot of data is messy and ugly and dirty and looks a bit like this. People have entered it by hand into a spreadsheet or a form, and you have this like time and materials entry. You've got 3 arrows pointing to it. You've got T and N. Someone else has written time and material. Someone else has written it in a plural. These are all 3 different ways. How are you supposed to visualize data when it's not got any consistency? So Google Refine is a tool to write a series of transformations to take messy data and turn it into data that you can actually then visualize and really analyze and understand. It works offline, but it handles fairly large amounts of data. It can handle the size of data that lives in Fusion Tables, and it remembers the transformations. So you define a series of transformations, and then you can reuse those on other data. So maybe this is the first expense report, and then we get some more expense reports in the future, and we can reapply the same transformation or make small variations or modifications to the steps. So once we have some beautiful data, we want to visualize it. So Google Charts is a really nice JavaScript interface for doing that. It means you can have your data visualized on websites in beautiful ways. You can do pie charts, scatter plots, you can build your own customizations, you can also do mapping. So this works both with Fusion Tables as well as with any other kind of data you have. So this provides a preset of templates of the way you might want data to look, a way to tell a story about the data. You might want to dig a little bit more deeply. So this presentation is meant to provide you with the links, where to get started, both with our tools and a few others. So that if you want to get in more detail and design much more customized visualization tools, there's a really fantastic library called D3, which is designed specially for visualizing data. You can do a whole bunch of other wild and fun data visualizations with it. We have a thematic mapping tool, which lets you do these very fun three-dimensional globes with data, for example, showing population sizes with bars coming out of the Earth. So it's a very fun, beautiful thing to play with. And again, all of these things have APIs so you can create and use the visualizations online with relatively little work. These are the kind of things that are perfect for hackathons. So there's just a couple more things I thought might be fun to show you. And I'm just going to jump out of the big screen to do a live demo, which they always tell you never to do, but I think are fun. So this is a visualization we did in Google Ideas on ARMS sales. So this was a large amount of data telling you who is selling ARMS to whom. So it's interactive. You can scroll it around and look. So we're currently focused on the United States of America, and this shows us all of the trade and arms sales that's going out of the United States of America. So we can see there's a lot going to Brazil. There's a little bit less going to Argentina. We could decide to look only at imports. Where does the United States of America import things from? So this is an example of a very beautiful, fun visualization. This is the kind of thing that probably is a little hard to do in a hackathon. This takes usually weeks to develop, but it's quite interesting. And it gives you an insight into the way money flows and the way weapons flow. A second example that you can look at online. This is the stars. This is 100,000 stars that have been visualized. So this is a Chrome experiment. The previous one was a Chrome experiment as well. This lets us kind of zoom in and out of the stars. We can go in and have a look a little bit more closely. We can get into our solar system. There's the sun. So we're 1 light year away. We can zoom in further. And here we get down to the orbits of the planets. We get Neptune, Jupiter, Saturn. And we get down right to look at the sun. Okay, so there's some fun, crazy technology. I'm going to now let you guys take it on. And I look forward to seeing what you build in the next few days. Thank you.